Welcome back, friends. In today's session we are going to discuss about the alternative respiratory substrates. So in the previous session we discussed about the concept of ATP summation and some other concepts. So it is better if you go to my previous session and then you view the session we discuss about the concepts of oxygen depth and things like that. So today we are going to continue with the alternatives respiratory substrates. Now we are saying that sugar are not the only materials which can be oxidized by cells to release energy. Both fats and protein may in certain circumstances be used as respiratory substrates. So if sugar is depleted in the body, then the body goes to use fat, and if fat is depleted, then the body uses proteins. So let's start with the respiration of fat in this session, and then in the next session we discuss in detail about the respiration of protein. So in the respiration of fat, initially fats are hydrolyzed by lipase enzymes into fatty acids and glycerol. So fatty is hydrolyzed by lipase to fatty acids plus glycerol. This is the initial process in the metabolism of fat. So from there we are going to discuss metabolism of each one of these. Glycerol as independent and fatty acid as independent. So by starting with glycerol is the first phosphorylated by using phosphate. So it is first phosphorylated. Glycerol, if you are phosphorylating by using phosphate from ATP, it will form glycerol phosphate. So glycerol phosphorylating it will get glycerol phosphate. Remember, glycerol is an alcohol, so this is the phosphorylated alcohol. Now glycerol phosphate is oxidized by NAD to dihydroxyl acetone phosphate, which is then converted into its isomer 3-phosphoglyceraldehyde. Now if you remember the stages of glycolysis, if you remember, we said that dihydroxyl acetone and 3-phosphoglyceraldehyde, they are isomer of each other. So by oxidizing glycerol phosphate, because this is an alcohol, so oxidation of alcohol we get carbonyl compound. As I said, the oxidation of alcohol we get carbonyl compound. Oxidation of carbonyl compound you get carboxylic acid. So glycerol phosphate, glycerol is an alcohol. We are oxidizing it to a carbonyl compound. How do we oxidize it? It's by removing hydrogen, because this NAD is the hydrogen carrier. So you see, phosphate glycerol to dihydroxyl acetone phosphate, it is oxidized by NAD, and then the dihydroxyl acetone phosphate, it is converted into its isomer, which is 3-PGAL. Phosphoglyceraldehyde, 3-phosphoglyceraldehyde. This 3-phosphoglyceraldehyde, as we know, is an intermediate for glycolysis. So it enters the glycolytic pathway. 3-phosphoglyceraldehyde is then incorporated into glycolytic pathway. In the glycolytic pathway, phosphoglyceraldehyde is further oxidized and phosphorylated to pyruvate. Kwa hii hapa itaingia kwenye stage ya kama stage ya 7 ya glycolysis, kama unakumbuka vizuri the stages of glycolysis. So that's how the oxidation of glycerol inakuwa inaenda. Hivyo ndivyo ambavyo metabolism of glycerol inakuwa. Now let's move to see tumalizia hapa metabolism of glycerol, then to move kwenda kwenye fatty acids, how the metabolism of fatty acid. Okay. Anyway, kwa tunachokisema ni kwamba if oxygen is present, pyruvate itaingia kwenye Krebs cycle, so is further converted to acetyl group, then acetyl coenzyme A which enter Krebs cycle to release 3 NADH2, 1 FADH2 and 1 molecule of ATP. Complete metabolism of glycerol yield 19 ATP, inatengeneza 19 ATP. Kwa hazifiki 38 because hii inaingia stage fulani ya glycolysis. Now from there tuingie kwenye metabolism of fatty acid. In matrix of mitochondria, fatty acids are oxidized by the process called beta oxidation. Means fragmentation of fatty acid molecule into 2 carbon fragments. So beta oxidation tunachukua fatty acid yenye urefu wote, because fatty acids normally unaweza kukuta ina carbon 20 ngapi 30. So we are taking fatty acids with any length, and then we are metabolizing it, or we are fragmenting it, we are cutting it down into small fragments. So by the process called beta oxidation means fragmentation of fatty acids molecule into 2 carbon fragments. The 2 carbon fragments are converted into acetyl coenzyme A. So the carbon fragments, they combine with the acetyl coenzyme A, forming acetyl coenzyme A, which then fed into Krebs cycle at a point where acetyl coenzyme A occur. Kwa hiyo acetyl coenzyme A zile zinaingia kwenye Krebs cycle. Kama unaweza kuona hapo, we have fatty acids, then they undergo beta oxidation to release 2 carbon fragments which are acetyl, then combine with the coenzyme A to form acetyl coenzyme A, then they enter the Krebs cycle. So in summary about the respiration of fat, oxidation of fatty is preceded by dehydrolysis to glycerol and fatty acids. The glycerol may then be phosphorylated and converted into triose phosphate, which is glyceraldehyde 3-phosphate, which is the summarization. In the previous explanation, we explained how this happened. This can then be incorporated into glycolytic pathway and subsequently the Krebs cycle. Fatty acid component is progressively broken down in the matrix of mitochondria into 2 carbon fragments which are converted to acetyl coenzyme A. So this is the summary taken from our understanding biology book. It is just the summarization about the respiration of fat, but it is not the details of every step which is taking place in the respiration of fat. But what I need you to know is about the details of every step which is taking place in the respiration of fat. So we are saying that this is then enter Krebs cycle with the consequent release of its energy. The oxidation of fats has the advantage of producing a large quantity of hydrogen ions, which when enter the electron transport chain, they release a vast amount of energy. So these can be transported by hydrogen carriers and used to produce ATP in the electron transport chain. For this reason, fat liberate more than double the energy of the same quantity of carbohydrate. Kwa hiyo tukichukua 1 kilogram of carbohydrate and 1 kilogram of fat will liberate more than double the energy ambayo inaweza kuwa liberated by carbohydrate. Why? It is because of the large quantity of hydrogen. Now swali unaulizwa, why fat respiration yield more energy than glucose? Why? Now the reason behind, first is fat is provided large number of hydrogen atoms which pass through the respiratory chain, yielding a large number of ATP than glucose. And the second reason is that fat have a high calorific value than carbohydrate. Calorific value is because tunamaanisha kwamba tukimetabolize few kilograms of fat tapata energy kubwa as compared with few kilograms of carbohydrate. Now let's move to a book. Here we have a book. It's the a cell molecular approach by Geoffrey M, which we used in the previous sessions to explain about the electron transport chain. Now in today's session in this book, we are going to discuss about the oxidation of fat, and this diagram here summarizes the oxidation of fat. And for example, here we have this fatty acid. And in this fatty acid, I want just to get a pencil here which I can use to draw and to show different things here. So for example, here we have this fatty acid. In this fatty acid here, this is our fatty acid. We have how many? We have 14 acetyl groups. We have methyl and a carboxylic group at this end. So tuna carboxylic, then we have acetyl, then tuna methyl group at the end. Now tunaangalia process ya kudeliver energy. How can we get energy from this fatty acid? That's what we are looking in today's session. How can we get energy? Now we have some of the few explanations here about how to get energy. Derivation of energy from lipids. Energy in the form of ATP can be derived not only from breakdown of glucose, but also from degradation of other organic molecules, with glycolysis and acetic acid cycle again playing central roles. Kuna kuja kuna mfano hata metabolism ya fat bado glycolysis inahusika na Krebs cycle inahusika. Now the two principal storage form of energy within cells are polysaccharides and lipids, which can be broken down as needed by the cell to produce ATP. Polysaccharides are broken down into free sugar, which are then metabolized by glycolysis and the Krebs cycle, kama vile ambavyo tulisha discuss previously. Lipids, however, are even more efficient energy store molecule because lipids, which consist primarily of hydrogen chains, are more reduced than carbohydrates. The oxidation of lipid yields substantially more energy per weight of starting material. Kwa oxidation ya lipid ina release energy kubwa. Unaweza kuona hapo tuna fatty acid. Fatty acid tunamfanyia kama phosphorylation kwa kutumia 2-phosphate. Lakini unaweza kuona hizi phosphate zenyewe haziingii kwa fatty acid moja kwa moja. Lakini this reaction maana yake ina release energy. Hiyo energy inatumika kutengeneza huyo hapo. Unaona ni 16 acetyl coenzyme A. That means hapa tuna huyo hapa tumemcombine coenzyme A na tumemcombine huyo hapa huyu group tumekuja kumcombine hapa. So that means oxygen imekuwa removed and also hydrogen is removed. This hydrogen and oxygen zimecombine kuform water. Zimecombine kuweza kuform water pale. Now from this one which is 16 acetyl coenzyme A, tuna reduce by removing hydrogen. This is the process of beta oxidation. It's not so much important for you to know the details of beta oxidation, but these are the reactions of beta oxidation, how they are occurring. This is the first step, this is the second step, but you can't be asked about the mechanism of beta oxidation, which are these reactions. Kwa fadi pale yakimoxidize tunakuja kupata compound kama yule pale. Compound kama yule pale tukija kuadd water tunampata compound kama yule pale. Compound kama yule hapo tukija ku remove hydrogen tena binary tunakuja kupata compound kama yule pale. Then tuna add tena compound mwingine coenzyme A tunakuja kupata acetyl coenzyme A yule pale pamoja na 14 acetyl coenzyme A. Kwa mfano huyu ni acetyl coenzyme A mmoja tumempata. So tunafanya hii process mpaka tutapata kuwapata acetyl coenzyme A wote. Maana yake ni beta oxidation imetengeneza acetyl coenzyme A moja. Hii reaction inatakiwa iwe repeated. So the fatty acid such as 16 carbon saturated fatty acid palmitate is initially joined to coenzyme A at the cost of 1 molecule of ATP. Degradation of fatty acids then proceeds by stepwise oxidation coupled to formation of FADH2 and NADH2 and the removal of 2 carbon units as acetyl coenzyme A. So let us go back here and read some of the information. Fatty acids and triglycerols are major storage of lipids. The first step in the utilization is the breakdown of glycerol and free fatty acids kama tulivyosema ni hydrolysis. Each fatty acid is joined to coenzyme A, yielding fatty acid coenzyme A at the cost of 1 molecule of ATP kama tulivyosema hapo mwanzoni kwamba kwanza ina join with coenzyme A pamoja na ATP. Lakini from there fatty acids are then degraded in a stepwise oxidation step, 2 carbon at a time, yielding acetyl coenzyme A plus a fatty acyl coenzyme A shorter by 2 carbon unit. Each round of oxidation also yield 1 molecule of NAD and FAD. The acetyl coenzyme A then enter the acetic acid cycle and the degradation of remainder of a fatty acid continues. So unaona kila cycle inakuwa ina release kitu kama hichi. Na inakuwa na release ngapi? 2. Kwa kama ina carbon 16 maana kitatakiwa ifanye cycle 8 ili iweze kufikia kitu kama hicho hapo, kama ina carbon 2. So from there tunachokisema ni kwamba the acetyl coenzyme A then enter the breakdown of 16 fatty acid, thus yielding 7 molecules of NAD, 7 FAD and 8 of acetyl coenzyme A. In terms of ATP generation, kwa sababu hapa ni 16 maana yake tutatengeneza ngapi? 8 acetyl coenzyme A. In terms of ATP generation, this yield corresponds to 21 molecule of ATP derived from NAD ambazo ni 3 mara 7 itakuwa 21. And 3 NAD 3 ATP 3 mara 7 itakuwa 21. Then 14 ATPs from FAD. So 21 molecules of ATP from NAD and 14 ATP from FAD, 2 times 7. And 19 from acetyl coenzyme A, which is 8 times 12. Kwa unaweza kuona ni how many molecule tunazipata kwa kurelease kwa kubreak down only 1 molecule of fat, how many ATP tunapata. So since 1 ATP was used to start the process, the net gain is 130 ATPs per molecule of a 16 carbon fatty acid. Kwa only 1 molecule tuna gain 130 ATPs. Kwa unaweza kuona jinsi gani ambavyo gain inakuwa kubwa kulingana na investment. So compare this yield with a net gain of 38 ATP per molecule of glucose. Since molecular weight of saturated 16 carbon fatty acid is 256 and that of glucose is 180, the yield of ATP is approximately 2.5 times greater per gram of fatty acid. Hence the advantage of lipid or fatty over polysaccharide sugars as energy store molecules in the body. So in the discussion about the metabolism of fatty acids, this is our discussion about the metabolism of fatty acid. If you need the book, this is the book. Unaona imeandikwa the cell a molecular approach by Geoffrey M. So if you need it, you can contact me, or anyway you can get it. Now this marks the end of our discussion in the respiration of fat. In the next session we will start discussing about the respiration of proteins, and we will discuss all the aspects about the oxidation, deamination processes and the uses of the end product of respiration of protein. Thank you everybody, and later I wish you nice studies. Thank you.